had it up. 1 second. Oh, here it is. All right. So let's kind of review this. So the first thing, right, is to make sure you kind of know the grain of the data when you're working with window functions. We said, like, by that, what we mean is, like, what does each row represent, and what are the different dimensions that are available to you? So here we just load in some data, and then let's just do a simple select statement. So select all from store transactions. All right. And that'll be our thing. And then we can do pd.readSQL, and here's my query, and then here's my connection. And now we can kind of see, again, like, what does each select date from? Like, what does each row represent? So each row represents, right, number of transactions per store on a given day. Okay? If you did, like, select star, just to be safe, you can see there really is no other kind of dimension involved here. Okay? So it's how many like transactions were there for each store on a specific day. And then we said, just quickly the difference, right, between window functions and group by is that group by is going to reduce the dimension of the data. So if you do something like, give me the average number of transactions, well, that's going to just give us back one row, okay, as average transactions. Whereas with window functions, the way window functions will work is here we have the transactions, and here we do the average transactions. We would have to do like over, and then once we do the parentheses, this is saying this over parentheses is indicating a window, and in this case the window is the entire data set. So this would give me not reduce the number of rows, but rather calculate this across the entire data set. And then from there you kind of build up. That's like how I generally write window functions, is then to just build them up. So what does that mean? The next thing would be like the partition by, right? So if we wanted to calculate the average, you can do like per store, so it'll be like partition by the store number. It might be the next thing, right? So this is now the same for store number 1, and this is the same for store number 54. And then from there, the next thing would be like if you want to do like a running total of the average. And for that, that would involve like an order by. Okay? So just remember this order by is going inside like the window function, and you can, if you do the order by outside, right? That's just determining, right, like the actual order of the data set. But it's not going to turn it into a running total. This will be the same. We could do it ID just to really see that. Order by the store number. So you can see that we are ordering the data set. I guess we're reordering it. But it's not giving us a running total. These are all the same. However, the second that we do partition by store number, order by, let's say order by date, right? So it's a running total for each day, going from the first day, so we'll say this is ascending, going from the first day the store sold something to the last, that will give us a running total here. So let's see. So this is the average transactions. So that's why this one is 998, and then this one is 998 plus 920 divided by 2 gives you something like 959. And then this one, this 794, right, brings it down to 904. And then that running total is going to start over again with every time you get to a new store, Okay. So this just must not be the first occurrence here, but, right, you can see it's all the way up to 2017. But, right, we're still doing, like, this running total. So this is what we really covered last time, I think, is window functions. We said basically window functions, they don't reduce the dimension of the data, right? And you specify a window which is like over what period, right, across which rows of the data are you performing this calculation on. Okay, so in this case, the calculation will reset for every store number. And the order by is what makes it a running total. The next thing we can see is essentially setting a sliding window. All right, so let's see what that will do. So here we can do order by date, and now instead of it being the entire, having a running total, let's do a sum here, and we'll call this as the running. It'll just make it easier to see. Running total of transactions. All right, so this is just a little bit easier because we can actually add a little bit. It's an easier calculation. So you can see that this is a running total. We have like 998 plus 920 is 1918, and then 794, right? Add this up, 1918 plus this gives me this, and then, right, plus this gives me this. So what you can do is after this order by, you can also kind of do this rows between, and that would be the sliding window. So we'll say rows between, one preceding, and one following. Okay, so rows between, if you're doing a sliding window, you're always going to say this rows between language, and then it's going to be like how many rows before and how many rows after. Okay, so in this case, let's see that. So we're going to see, let's just press shift return. So what's this one? Well, there is no row preceding, right, for this row. Right, to get to this number, it'll be the row preceding and the row following. So the row preceding is 0. So it's 0 there. And then the row following is 920. So that gives you, what, 1910 plus 8. So that's where you get the 1918. For this one, it's going to be one row preceding and one row following, so that you're going to add these three numbers up. So it'll be like that 1910 number, 1918 number, plus 794, and that's going to give you the 2712. Right? Notice this number doesn't keep getting bigger, because once we get to this one, now what's the window? The window is this, this, and this. Right? So each time you kind of calculate, you can imagine like a, almost like an index card on either side or something like that, where you're just sliding that thing down, right? Like a little, like literally like a little window or like a little opening in it, maybe in an index card. And this one's just 3 rows deep, and just slide it down. All right. So what does that mean? It means if you're going to calculate, let's say we do this one. Well, what's the window for this number? One preceding and one afterwards, right? So that means it's 570 plus 416 plus 1,000 is something like 986 plus 4 is the 0, right? It gives me the 1990. So whenever you look at a row, it's just, in this case, right, it's one preceding and one after should give me this number. This guy, these 3 rows, give me this number. And again, how do we do that? We're ordering this by the date, like we're getting this calculation, partition the store number, order by the date, and then here it's specifying the size of the window. The one before and the one after. And you can change that, obviously. You can do 2 before and 2 after. So you basically get this preceding language, and then the other thing you get is current row. So if you don't want to do something following, or you could say rows between, and you could say the one preceding, the one before, and the current row. Okay, so what would that do? Right now, this number is 1918 because I didn't press shift return yet. So it's this row plus this one. But once I move it to current row, this value should become 998, right? Because there is no preceding, and it's going to stop here. And then for this guy, it would be one preceding would be like 998 plus 920, which would be like 1818 or something like that, right? I think 1918. One preceding in the current row. Yeah. So let's press shift return. We'll see it. So you can see, right, now we're just stopping at the current row, so there is no one preceding, so that's why it's 998, right? And then this one, there is one preceding, so this guy plus this guy equals this, right? So what is this like kind of like sliding window about? Like what is the use case for it? It is all about basically like moving, or maybe you could call it like rolling averages. Or basically the idea, if you do like rolling average of like S&P 500. The idea is, I wish there was an image. Okay, this is a good example. So this is the idea, right? The idea is like, there's all these kind of gyrations if you do like the daily movement, but unless you're a day trader, like you really care about like the trend over a period of time. So you don't want to be super influenced by like these daily changes, and maybe you want to see like in general, how did it do over this period, and then what happened here, right? You're trying to smooth out the trend. And right, you can imagine, right, there's a lot of use cases for this, like sales, right? Like the average amount of sales, I don't care, or I don't care maybe the average every day, how it's going to change, but just give me like a 5-day average, right? Or average temperature over 5 days, something like that, right? Like if you care about like global warming, again, like one day isn't probably the way that you want to measure that, but yearly or, monthly, like, or month over month, like, right? Like you could see how like smoothing it out can give you more of the analysis that you're looking for. So that's what these sliding window functions are all about, is not having something depend on just that one row, but the rows around it, okay? So that's really like the use case for it. There's something similar to it, which is that lag function that we saw previously. And whereas like sliding windows are about rolling averages, the lag function, this is really, here you're only going to you just get one row to compare the current row to. All right, so let me just show you what I mean. So with the lag function, it would be, let's say we take let's just do the current number of transactions. We'll just delete this row. So this is just simply me selecting from. So I'm just selecting the entire table, okay? We don't even need this order by. And now let's do the lag function. So we'll do transactions, comma, lag transactions. And then you can just see as previous day's transactions. But I want to say, like, what does it mean to be the previous day? So I'm going to say this over, and then I'm going to say, I would probably do partition by the store number, right? Because I have multiple stores, and then order by the date. So the previous day means that each store's previous day, right? Order by date, probably ascending, right? Going the earliest to latest. Yeah, and let's do that. So here, they were at store number 1, January 2nd, 2013. There is no previous day, right? So that's why it's not a number. It's null in SQL, but Pandas translates it to not a number. So here's the transactions, here's the previous day transactions, right? And I think we've seen this, right? What we could do is we could calculate the difference if we want. We could go like, this guy minus that. Like, what is the increase or decrease? The other thing I wanted to show you is, you see, this is null. If you want, you can set the default value. So I'm just going to do that. I'm going to do 1, 0. So this 1 is to say, like, just look back one day. And the 0 is to say, when there is no kind of previous day, set the value as 0. So you just know that you can do this, right? So this is now changing it from null to 0. You can set it probably like whatever you want. Like you can do negative 99, but I'll just do 0. That's one thing you can do. And the other thing you can do is, here we're looking back previous day, but you can also go 2 days prior if you want. So what would that, so we can just that. So now there's Here there's no previous day or previous, 2 days ago, right? Here there's also no previous 2 days ago, right? There's yesterday, but not the day before. Here we finally have 2 days ago, right? 1863, 21111, right? So you can have the look back be 2 days ago or however many days ago you want. The one thing I wanted to clarify is it's not rolling, right? It's not including, this isn't looking at this plus this, right? It's just skipping over to get to that, right, 2 days ago. So down here, 2 days ago would be right here, right? And that's what we're getting. So what is this useful for? This is for like comparing previous like occurrences, right? So it's like, so in this case, it's this amount of transactions versus the previous amount of transactions. I gave, and again, like you can kind of work with this. Let's say if we just do 1 day prior, what you can do is transactions, previous transactions. From there, you can just, subtract it. So transactions minus lag. So this would be today, how much greater or less than the previous day. This, and we'll do difference in previous day transactions. Okay, so here there's no difference. Here it's actually less, right, than the previous day by 278. Cool. And then the final thing to know is just that I did give some use cases of where you can use lag. So I think that's worth looking at because, and I'm just kind of summing up the end here, right, what I've been talking about, that sliding window functions are for rolling averages, right? It's for like smoothing it out. Lag is for comparing the last occurrence. So we just saw like difference in sales for consecutive days. Another good one is like time since the last event, right? So basically here, I don't know if you can see this, it's comparing like a user's login time, right? This is their, for this row, this is their login time, and then this is their previous login time, right? Partitioned by a user ID, order by login time, show me the previous one, right? Go one back. And then here they're actually seeing, how long between events because they're comparing one login. I wrote it down. It's like they're comparing one login, one login versus the existing one. It's hard to see in the font, but that's what it's doing. A year-over-year comparison. I thought this was interesting. Right here, they're comparing like January 2024 versus January 2023, right? Because they're partitioning by month. So every month is what they're comparing by, is what the look back is. And then they're ordering by year, right? So it'd be like January 2024. The previous row would be January 2023. And then they're saying, what's the difference in revenue, right? From this year's January versus previous year's January. So these use cases are, I think they're valuable to move through as to how you can use this. This I found interesting, right? The status change. So here what they're doing is they're saying, okay, let's say we have, when an order moves from pending to shipped. So the way they do that is they select what's the current status. So let's say the current status is shipped. And then this is a look back to the previous one, right? So that would be like pending, so you can kind of see what's the state change. And you can imagine, filtering, like show me all the ones where it goes from like pending to canceled or something like that, right? Like, because there could be some combination of events that are interesting. So you can achieve that by using the lag, right? So these are worth, I think, there's only a few of them that I found interesting, but I think they're worth looking at. And then, of course, we can move into some LeetCode problems, all right, from there. Questions about this, right? So we covered like sliding window functions, lag, and then just reviewed window functions in general. Okay. one thing that's going to be worth reviewing for the LeetCode functions, especially, is going to be this rank based function. Specifically, just to like give you a little bit of hint, row number. Play around with row number. It's interesting. We can cover it later, but yeah, like they come up. Row number comes up a lot in LeetCode problems. All right. So anyway, we're going to experience that a couple times today. All right. Let me put you into breakout rooms. So in terms of what to work on, you can review the rank based. This lesson especially. I'll deploy the solution if you want. We have this lag use cases. And then here's a sliding window lab. And then I'll deploy a couple of these. Here's power users. And then if you can get to it, this one's challenging. But even this one will be great.